Come on. Okay, so today, guys, we're going to be going over the third rule. We've done the multiplying powers with the same base, the dividing powers with the same base, and today we're really going to be talking of power with exponents. So we're going to be doing some more examples in class, kind of like what we did the other day. So we really need to make sure we know what these things mean when we're asking to expand or simplify to hopefully figure out the rule. So what I need you to look at is right here. We need to make sure we know that that 3, that exponent, what is the base for that 3? Well, because it's in parentheses, it's everything inside of that parentheses times everything inside that parentheses times the same thing inside that parentheses 3 different times. So what that looks like this, 2x times 2x times 2x. And then we can rearrange things and simplify from there. Okay, so kind of similar to what we did the other day. So the first example that I'm giving a group looks like this. Well, we have m to the third, and we have that to the second power. So what does this really mean? That means I have two of these is what that's really telling me. So as we go to expand that, it looks like this. I have m times m times m, and I have that twice. So now when I go to simplify that, that's m, and I have 6 of them, so m to the 6th power. So look back at the original problem, look back at those exponents. Where is that 6 coming from? Okay. Example 2 looked like this. A to the 2nd power, so a times a, and I have that 5 different times. Okay, so I have that 5 times. Whatever is in here, 5 times. So expanded, that looks like this. A times a times a times a times a times a, have that 5 times. Now how could I write this as simple as possible? I have 10 a's. A to the 10th power. Now look at your exponents. Where did that 10 come from? Okay, next example. The third example looks like this. So I've got, that we did in class, so I've got whatever's in here times whatever's in here times whatever's in here. I have that 3 different times. So what that would look like expanded looks like this. That's 2x to the 4th, 2x to the 4th times 2x to the 4th. Oops, that x should be really up here. Okay, now rearrange it a little bit. Let's put all our coefficients together and put all our x's on the other side. So I get 2 times 2 times 2 is 8, and then I have 12 x's. So where did that 8 come from? And where did that 12 come from? Up here. Okay, so we'll be looking at that a little bit further. See if you spot it. Example 4 looked like this. That means I have whatever's inside of my parentheses twice, because the 2 is, this is the base, so whatever is in there 2 times. So expanded looks like this. 3 and then 6 p's and then times the same thing twice. Now rearrange it a little bit, move those 3's together, move all the p's over to the other side. We end up with 9 p to the 12th. Well, where might that 9 be coming from, and where is the 12 coming from? Okay. The next example and the last example looked like this. So this one was quite a doozy that we did in class, but we have this whole thing expanded, and we have this twice. So we have a 4 and 2 x's and 3 y's, and then we have another 4 and 3 and 2 x's and 3 y's. So we have the same thing twice. So that's why it's to the 2nd power. So then rearrange everything and reorganize it, because it doesn't matter if we multiply in different orders. So the 4 and the 4 go together. I have 4 x's and then I have 6 y's. So 16 x to the 4th, y to the 6th. So where might that 16 come from? Where might that 4 come from? And where might that 6 be coming from? Okay. So on to our notes now. Here's your examples that go out on front on the power of power. Okay, the rules themselves, if you open up that, so here's the examples that go out front, open up that foldable, and here's the rule. Okay, the rule is that we're multiplying our exponents in this case with power of a power, and we're really distributing that exponent to everything inside that parentheses is really what happened. So based on those two examples we had out front, 3 to the, or x to the 3 times the 4 is going to give me 3 to the 12th, or x to the 12th, and that y to the 5 times the 4 would give me 20 y's. So you can kind of see that distributing piece and where that comes from. So the answers as well, so that 3 gets distributed to the coefficient, and really that's a 5 to the first power, and then it gets distributed to that 2, and then it gets distributed to the b, which is 1 times 3. If there isn't a 1 there, you can always add it, and then c to the 4 times the 3. So really it simplifies down to 5 to the third power is 125, a to the 2 times 3 is 6, b to the 1 times 3 is 3, and c to the 4 times 3 is 12. So it's really all about distributing that exponent to everything, including the coefficient inside the parentheses. That's what power of a power is. So here's the other examples that we would be doing in class. So we're going through and distributing that exponent to everything in there. Go ahead and pause me, try these on your own, and then come back and see how you did. All right, let's see how you did. So if we're distributing that 2 needs to go to the a. Even though there isn't an exponent there, there's really a 1 for an exponent there. So a 2 times a 1, and then a 4 times a 2 for the b. So you get 8 squared times b to the 8th. The next one, you're distributing the squared to the 5, so 5 squared and x squared. So 5 squared is 25. X squared is what it is simplified. The next one, we've got 2 to the third power, c to the 3 times 3. There's really a 1 here for the d. D to the 1 times 3, and f to the 5 times 3 simplifies down to this. And then the last one, you've got a to the 3 times 4, b to the 2 times 4, and there's really a 1 here for that exponent. C to the 1 times 4 gives me c to the 4th. So this is the power of a power rule, and now you'll have some homework based on this rule. So if you need to go back, re-watch, or look at any of those examples again, feel free to.